Good afternoon, M1s. How are you? Miss your faces already. Today we're going to be doing a relatively easy topic called surface area. Now, re-watching this little animation, what do you think surface area is about? Watch the animation again now. I want you to pause the video and have a little reflection on what you think it could be about. Hopefully, you came to the conclusion that surface area is to do with the area of each of the faces of a 3D solid, and we're going to go through some specific examples. What we need to do when calculating surface area is to find out how much of the surface we can see on the outside of the shape. We measure it with square units. I would like you to copy this down in your books. So in order to work out how surface area is calculated, the first thing we need to do is work out the area of different faces. And as we've done before, area is really straightforward. And I've got 3 examples here, and you can always pause the video if you want to recap area. But I think most of you are quite strong on this topic. The only one I would take care on is the triangle. Some of you have been making little mistakes on this. So remember, a triangle is base times perpendicular height, and then you've got to cut it in 2 because it's half a rectangle or half a square. So this is going to be a quick recap on working out the surface area of a particular shape. We're going to start with this particular cuboid. And we know it's a cuboid because all the sides are not necessarily the same, they're different. Whereas a cube would have all of the same sides. So the first thing we're going to do is calculate the area of the front face. This is really straightforward. 6 centimetres base and 5 centimetres height. Now you might struggle seeing that this 5 centimetres is the same as this front 5 centimetres, and this is because these 2 sides are parallel and the shape is a cuboid. So you do this times this, it equals 30 centimetres squared. Can you pause the video and have a think about why it is just centimetres squared, not centimetres? Great, hopefully you realised it's centimetres squared because all 2-dimensional shapes, as in this shape itself, the face of the cuboid, gives a power of a 2. Next shape we're going on to is the back face, and now you can see they're exactly the same, and we're going to have this lovely pattern with a cuboid or a cube where we have 3 differing faces and they are repeated each twice. So again, this is also going to be 30 centimetres. Now we're going to calculate the top face. This is a little bit different. We've got 6 as the base, and then we have the width of the triangle, or the height of the triangle is 3 centimetres. Similarly, the bottom is going to be the same as the top. They have a same relationship because they are both the same faces but moved. Final types of side is going to be each of the sides, and each of the sides again are the same, 3 times 5. So all you need to do to find the total surface area, you add all of these numbers together, giving us 126. So that is relatively straightforward. Another way you can think about this is in terms of a net. So we've been studying nets, and you know this quite well. So if you weren't confident in picturing the shape, what you could do is you could unfold the cuboid, and what we'll end up finding is the area of each of the faces. So we can find the area of the bottom face, which is here, top, left, right sides, back and front. For some of you, you might not need to do this. And last but not least, if we're focusing on finding the surface area of a triangular 3D shape, I'm going to show you how to do that now. So the final example I'm going to go with you is finding the surface area for this particular shape. Let's go. First thing we're going to do is calculate the base, 3 times 3. Next thing we're going to do is calculate this side, the dark pink, 5 times 3. Another one we're going to do is 4 times 3. And then the final one is the back one and the front one, which are both identical. And then all you need to do is work out each of these 5 faces and add them together. Pause this video if I'm going too fast.